How many ways can we choose two different numbers from the following set of numbers? And we'll write all the possible two permutations to verify our result. So what we're choosing is two distinct numbers from a set of four numbers. So therefore the number of two permutations can be calculated using n factorial over n minus r factorial. So that gives 4 factorial on 2 factorial, which is 12 two permutations. So let's write out the possible two permutations to verify our result. So from this set, we can have 1, 2, 1, 3, 1, 4, and 2, 1, 2, 3, and 2, 4. And the same goes for 3. And finally, for 4. So we have 12 two permutations, being the number of ways we can arrange two distinct numbers chosen from this set of four numbers. Now in the next example, we're asked how many different executive committees can be chosen from a basketball club which has 43 members. So here we have n is equal to 43. And the committee consists of the president, vice president, treasurer, secretary, and chairperson. So what we're choosing is 5 distinct people to fill that committee. And here we see that order matters because we can have people allocated to the roles of the executive committee as follows. So we have the president, the vice president, the treasurer, secretary, and chairperson. And you might end up with someone else filling the vice president and president role, for example. So therefore the number of different executive committees is the number of 5 permutations. So that will be n factorial on n minus r factorial. So basically this is the number of ways we can choose those 5 people to fill those executive roles from a club which has 43 people. So this would be equal to 43 factorial on 38 factorial, which is equal to 43 by 42 by 41 by 40 by 39, being the number of different executive committees that are possible.